of them should be in the same direction for equilibrium. Why? This is 2 times T2. When you simplify, it is S divided by 4. IR radiations give you better clarity than visible light. Why? So the number of significant digits is 5 and 7. Area of this triangle, there is a triangle here, half base into height. Hello students, this is Samson Deepak, Faculty of Physics, Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Today, we will be solving the Karnataka CET paper on physics for the year 2009. Probably I can say one of the easiest paper that can be analyzed. No complicated mathematical calculations. This paper does not require the depth of the concepts. If you have learnt the concepts on its surface, analysis of this paper is very, very simple. The first question. The number of significant figures in the numbers 4.8000 into 10 power 4 and 48000.50 has to be given. ಎರಡು ನಂಬರ್ಗಳನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. Using the laws, we have to identify the number of significant digits in them. Significant ಅಂದ್ರೆ ಏನು ಮಕ್ಕಳ? Weighted digits, certain digits up to which you can rely its value. Close to no error value. They are called significant digits. So in your 11th standard, we have a very unique description on significant digits. You are taught a set of laws to identify significant digits. So the first number 4.8000 into 10 power 4. The rule says any power to the base 10 should not be considered to identify significant digits. 10 power ಎಷ್ಟೇ ಇದ್ರೂ ಪಾಸಿಟಿವ್ ಪವರ್ ಆಗಿರಬಹುದು ಅಥವಾ ನೆಗೆಟಿವ್ ಪವರ್ ಆಗಿರಬಹುದು. You are not considering any power to the base 10 to identify significant digits. So 10 powers are ruled out from the significant digits. What about these 3 zeros? Are they significant? Very much yes, because there is a decimal point. Number of zeros following a decimal point are considered to be significant. So we have 1, 2, 3, 4, 5. So there are 5 significant digits in the first number. And again here, 1, 2, 3, 4, 5, 6, 7. So the number of significant digits is 5 and 7. So the option which is correct is the first one, 5 and 7. The second question, beta decay means emission of an electron from. My dear students, beta decay is a very, very unique process. ತುಂಬಾ ಯೂನಿಕ್ ಆಗಿರೋ phenomenon. This beta decay comes into picture when there is interconversion of nucleons. A very special phenomenon. Interconversion of nucleons. Nucleons ಅಂದ್ರೇನು? Protons ಮತ್ತೆ neutrons. By some mechanism, the nucleus of an atom loses its stability. Why? There is beta decay. There is interconversion of nucleons, which means a proton gets converted into a neutron, or a neutron gets converted into a proton. ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗೆ ಯಾವುದೋ ಒಂದು ಕಾರಣದಿಂದ ಒಂದು ಪ್ರೋಟಾನ್ ನ್ಯೂಟ್ರಾನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಬಹುದು, ಅಥವಾ ನ್ಯೂಟ್ರಾನ್ ಪ್ರೋಟಾನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಬಹುದು. This leads to the excess of either a proton or a neutron inside the nucleus. Stability is lost. And when the stability of the nucleus is lost, such an element becomes radioactive in nature. Least stable elements, radioactive elements. So beta decay is the emission of electron from a radioactive nucleus. Moment beta decay happens, stability is lost, excess of one nucleon comes into picture. That is what we call from the radioactive nucleus. Next one. An electric heater rated 220 volts and 550 watts. Potential or voltage is 220 volt. Power is 550 watts. Is connected to an AC circuit. I have to calculate the current drawn by it. The only parameter I require here is an expression which will relate power, voltage and current. And we clearly know these quantities are related by the expression P equals V into I. Power is equal to V into I, or I is equal to P divided by V. How much is P? 550. How much is V? Very simple calculation. This is 55 by 22, which has to be nearly 2.5. So the answer is 2.5 ampere. So very clearly you see, I am not using any astrophysics here. Simple relations, juggling out the required answer. Next one. This is an interesting question. Mechanics. A body of mass m moves along a straight line. One-dimensional motion. So there is a body of some mass m which is moving along a straight line, covers half the distance with a speed of 2 meters per second. It is covering half of the distance. So I say the actual distance covered is 2s. Half the distance covered, I say, is s. In a time interval t1, and the speed to cover half this distance is 2 meters per second. So total distance traveled is 2s. Half of the distance is s, covered in a time interval t1, speed 2 meters per second. Now comes the glow for the question. The remaining half, the other remaining half is covered in 2 equal intervals. The remaining half is covered in 2 equal intervals. So equal intervals T2, T2, which means to cover the remaining 2 equal intervals for successive halves is defined. ಇನ್ನು ಉಳಿದಿರೋದ್ರಲ್ಲಿ the first half is covered at a time interval t2, next half is covered at again an equal time interval t2, which means the next half of the distance is covered in a time interval 2t2 with a speed of 3 and 5 meters per second. The average speed for the entire journey is asked. Let us go back to the definition of average speed. So it is total distance divided by total time taken to travel. That distance, alva? Very elementary definition. Average speed is total distance divided by total time taken. This is total distance is what? 2s. The body is covering a total distance of 2s divided by total time taken. First half of the distance is travelled in a time interval t1 plus next half in two successive intervals of time, two equal intervals of time, t2 plus t2, which is 2t2. So this is 2s divided by, what is t1? Speed is distance by time. So time is distance by speed. So s by 2. Distance is s by 2 plus, this is 2 times t2. When you simplify, it is s divided by 4. So when you just simplify this, the answer will be 8 by 3 meter per second. Simple. If you try to draft the question, you will easily arrive at the solution. The moment of inertia. Nodi alli enu calculation keltilla ivaru. Moment of inertia of a circular ring. I always say in my discussions, you should know the moment of inertia for any object. Nalko itharadu object ide. Ring, disc, yes, wire, straight conductors, rectangular block, about some axis passing. So moment of inertia of a circular ring of radius r and mass m. Come on students, recall. Moment of inertia for a circular ring. It has mass m, radius r, and the answer is half mr square or mr square by 2. Next one. Now, a body of mass 0.05 kgs is observed to fall downward motion. It is coming down with an acceleration 9.5 meter per second square. The opposing force of air on the body has to be calculated. And there is a body of mass 0.05 kgs which is falling down. It is accelerating downwards. It is coming down with a certain acceleration. So here there is a downward force which is nothing but the weight of the body, and the opposing force of air. So the problem says there is an opposing force which is caused by air. ಈ ವೇಟ್ಗೆ ಒಂದು ಅಪೋಸಿಂಗ್ ಫೋರ್ಸ್ ಇದೆ. That opposing force is created by air. I have to calculate this opposing force. So the downward force is mg minus opposing force is F air, and this is mass into acceleration. So F is m into a. So resultant force is mg minus F air. That means F air is mg minus ma. How much is m? 0.05. G 9.8 minus A 9.5. 0.05 into 0.3. What should be the answer? 0.015 Newton. See, so trivial. Just to know the concept, rearrange, substitute. It doesn't take more than 1 minute to answer. This is actually from the previous syllabus. The colloidal solution in which both the dispersed phase and dispersion medium are liquids. They are called as emulsions. I don't take up the discussion because you're not exposed to the theory. It is emulsion. Next. In fog, photographs, pictures of the objects taken with infrared radiations, IR radiations, are more clear than those during visible light. Why? Andre intense fog conditions. Fog andre hima anta ankolana. When you take a picture or a photograph when there is intense fog, IR radiations give you better clarity than visible light. Why? ಹಿಮ ಬೀಳ್ತಿದ್ದಾಗ ಫೋಟೋಗ್ರಾಫ್ ತೆಗೆದ್ರೆ IR ರೇಡಿಯೇಷನ್ಗಳು ವಿಸಿಬಲ್ ಲೈಟ್ಗಿಂತ ಉತ್ತಮ ಕ್ಲಾರಿಟಿ ಕೊಡುತ್ತೆ. ವೈ ಈಸ್ ದಿ ಆನ್ಸರ್. ನೌ Rayleigh's law says intensity is proportional to lambda to the power 4, or we say intensity of the scattered light is inversely proportional to the 4th power of the incident wavelength. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, as wavelength increases, intensity decreases. As we see with this relation, as intensity or wavelength increases, intensity decreases, which means scattering of light is less. So wavelength ಜಾಸ್ತಿ ಆಗ್ತಿದ್ದಂಗೆ the light gets least scattered. The scattering of infrared light is less than visible light because they have high wavelength and as the consequence of Rayleigh's law. So the correct one is the third option. IR radiations to wavelength visible light ginta ಜಾಸ್ತಿ ಇದೆ. So IR radiations kadme scatter agutte. So the picture is more clear. 3 concurrent coplanar forces, 1 Newton, 2 Newton and 3 Newton act on a body in different directions. My dear students, if a system of forces act on a body, at least 2 of them should be in the same direction for equilibrium. Why? The third force, the resultant, which may balance the other 2 forces acting in the same direction. But very clearly here, all the 3 forces are acting in the opposite direction or different directions, which means the system cannot be in equilibrium. These 3 forces cannot keep the body in equilibrium. Sound waves travel, and what do they carry or transfer? Any wave will transfer both energy and momentum. This is already worked out in the 2013 paper, Compression of Springs. Please to refer, please to work out. Don't leave it stray. I leave it pause because I have done, I want you all to work out. So 0.05 meter will be the answer. G.P. Thomson experimentally confirmed the existence of matter waves by the phenomenon diffraction. If you remember the experiment, recall the experiment. In G.P. Thomson's experiment, the electrons are diffracted by the atoms of the crystal. Whatever crystal was used, so the electron is getting diffracted. The moment the word diffraction comes into picture, this is nothing but establishes the wave nature. Now ಓದಿದ್ದೀವಿ diffraction, interference ಅಥವಾ polarization establish ಆಗಬೇಕಾದ್ರೆ we have to consider wave nature. Since electrons are getting diffracted in the experiment, that means electrons also have wave nature. That wave nature with moving material particles itself is called matter waves. So which phenomena establishes the existence of matter waves? It is diffraction. The next one. Yeah, I don't go deep into this. This is again from temperature coefficient of resistance, which is not discussed in your syllabus. So you may be meekly exposed to that, but when we come up with the next sessions, we go over a note on these topics. Now, the work done by a force acting on a body is as shown in the graph. I have to calculate the work done in covering an initial distance of 20 meters. So this is force, this is displacement. So work done will be the area under the force displacement graph. Work is force into displacement. So we are asked to calculate the work done in covering a distance of 20 meters. This is my focus, 20 meters. Fine. So I told work done is the area under the given graph. The graph is the force displacement graph. So work done is the area under the graph, which is equal to, first we find the area of this trapezium, the first part of the curve, the first part of the area trapezium, which is half. Yes, the base is 15 plus 10 into 10 plus area of this triangle. There is a triangle here, half base into height. Half base is 20 minus 15, which is 5, into height 20 minus 10, which is 10, plus there is a rectangle here, length into breadth. So 10 into the breadth, which is 5. Very simple. I have just demelted the graph into 3 segments: trapezium, triangle, and rectangle. So this is 5 times. So 25 into 5 plus, so 25 plus, so this is 125 plus 75. So when you substitute or when you solve, you get the required answer. Now, 2 luminous point sources. Luminous, keep in mind, luminous point sources separated by certain distance are at 10 kilometer from the observer. ನೋಡಿ, 2 luminous point sourceಗಳಿದೆ. Luminous, they emit light. They are separated by a certain distance, what I call as A. And here is the observer who is at 10 kilometer distance from the 2 sources. If the aperture of his eye is 2.5 into 10 power minus 3 meter, and wavelength of light used is 500 nanometer, then what is the distance of separation between the 2 points? ಅವ್ರೇನ್ ಕೇಳ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ, ಎರಡು ಪಾಯಿಂಟ್ ಸೋರ್ಸ್ಗಳಿವೆ. They are separated by a distance what I call as A. Here is an observer. He is observing the point sources. Aperture of his eye is 2.5 millimeters. And to observe, wavelength of light used is 500 nanometers. ಈ ಎರಡು ಪಾಯಿಂಟ್ ಸೋರ್ಸ್ಗಳ ಮಧ್ಯೆ ಇರೋ ಸೆಪರೇಷನ್ ನ ಕೇಳ್ತಿದ್ದಾರೆ. Now, how do we go about with this problem? We use Rayleigh's criterion. What does Rayleigh's criterion say? Come on, students, just go back to Rayleigh's criterion. So, 1.22 lambda divided by, yes, very good, theta will give you, yes. So, this is 1.22 into 500 into nanometer, 10 power minus 9 divided by 2.5 into 10 power minus 3. So, when I simplify, 2.44 into 10 power minus 4 radian is there. But that is not what is asked. I want this A. So this A is 10 into 10 power 3 into this D. 2.44 into 10 power minus 4. So when we simplify, the answer turns out to be 244 meters. So the answer here is 244 meters. Again, see, so simple. Next one. A door of 1.6 meter wide requires a force of 1 Newton to be applied at the free end to open or to close it. Andre, to open a door or to close a door, what is that basically I require? Good, torque. So, I have to apply a force of 1 Newton to open a door whose width is 1.6 meter. Then the force that is required at a point 0.4 meter from the hinges. Now, we know torque is force into displacement. So torque is force into displacement. So torque is 1, displacement is 1.6. So it is 1.6 Newton meter. From the same expression, now I want force. Force is torque by distance, 1.6 divided by, now the distance is 0.4. Simplify, 4 Newton is the answer. Again, I have worked it out in the previous session. 65 degrees Celsius is the answer. the spectral lines of the hydrogen atom that lies in the visible region of the spectrum. Come on, recall your hydrogen spectrum, Lyman series, Balmer series, Paschen, bracket, Fund. Lyman series is present in the UV region. Balmer, visible. The next three, infrared. Near infrared, middle infrared, and far infrared. So which region is lying in the visible region? It has to be Balmer. Graph of pressure versus volume. PV graph for an ideal gas for different processes shown. For the curve OC, see, as volume is increasing, pressure is decreasing, and no heat is entering the system nor going out of the system. So this is an adiabatic process. Which of the following does not hold good for thermal radiations? The properties of thermal radiations are exactly the same as light traveling in a medium. Speed changes when it travels from one medium to another. Yes, like light, which has maximum speed in air and its speed decreases in material medium. They travel in straight line, very much yes. Wavelength changes, yes. Frequency changes, no. When a wave travels from one medium to another, its frequency always remains the same, and this is the wrong statement. Simple assertions. I don't have any magic to solve here.